Welcome to Forecast Force. We're tackling Challenge 5, risky resource routines, pinpointing patterns for preventing poor practice. Our project is all about empowering organisations to move from reactive firefighting to proactive, confident delivery. Forecast Force team comprises of Hannah Williams of Thales, Stephen Frost, Thales, Ron Stanworth from Toolstation, Roger Shupp from Thales, Lorraine Birchall from the MOD, Dan Bradbury from EDF, Megan Wardle from Thales.
Too often, task managers, project managers, and budget holders only spot problems with resources or budget after they've already impacted delivery. It's tough to drive behavioural change when reactive habits are the norm. We saw the power in supporting teams with proactive visual prompts, regular reviews, trend analysis, and data deep dives to highlight issues early. We focused on building a standard, structured format for open, honest discussions, fostering a culture of truth, learning, and solutions rather than blame. Our solution is a data-driven system that brings risky behaviours and planning patterns into the spotlight. With timely early warnings, both teams and leaders are alerted, making it possible to act decisively before a small issue grows into a costly setback. We set out to develop a behavioural analytics tool. This tool shines a light on inaccurate forecasts and flawed planning habits, helping teams understand why forecasts go wrong, where errors are recurring, and which behaviours need to shift for greater confidence.
We constructed our dashboard on Power BI as it offers flexibility and scalability in alignment with the expected data structures and format that resource and cost data is typically provided. In addition, Power BI integrates into Microsoft 365, which offers the opportunity for further enhancements through the implementation of Power Automate, as well as improved security features to secure and manage sensitive data. Working off the assumptions that the source data provided will remain in an Excel format, we combine, transformed, and cleaned the data within Power Query to ensure that the data is suitably set up for success within the data model. An example would be removing insignificant special characters to return a clean and structured configuration identification at a portfolio, project, resource, and work pack level. This configuration acted as the unique identifier between the data sets. We then merged the source data within Power Query with a data set from our large language model to create a seamless connection. We have produced two tabs. The first tab is predominantly descriptive analysis insights for visibility on the current schedule and cost performance at a granular level. This allows us to identify problematic trends in the scheduling and resourcing. An example would be we added the variance between the baseline hours and actual hours at completion, and then applied a percentage parameter to identify large deviations that could indicate forecast quality. We then used the average function to produce a card that is indicative of the scheduled adherence for a quick dynamic snapshot performance indicator. The second tab provides prescriptive analysis, which is supported by a large language model. We produced a script in Python to baseline the specification for the LLM to process against when identifying key behaviors and advisory actions within the source data. This tab provides the visibility of the problematic areas in relation to scheduled adherence and performance and provides advisory actions to support improved decision making. In addition, we have used the inbuilt AI functions to provide a dynamic key influences table that highlights the occurrence frequency of behaviors within the forecasting. All visuals can be filtered down to a granular level to accommodate different reporting levels.
These are the assumptions and the exclusions. Judges' questions. Question 1. How did you clean and prepare your dataset to ensure your Power BI visuals and forecasts are reliable and meaningful? We've cleaned the data in Power Query. This is using the combine and transfer function. In addition, we've removed the split by delimiter to remove unwanted special characters. This generates a unified, unique identifier to merge the datasets. We've removed incorrect data, specifically negative planned durations and negative actual durations, which are impossible. And we've also excluded any projects which haven't started yet. Question 2. Can you explain how your Copilot advisory system interprets the LLM identified behaviors to guide users towards better forecasting decisions? So we've applied the Copilot advisory system within Power BI to the output of our LLM behavioral analysis to summarize the categories and number of occurrences of behavior shown within the data. This helps users to navigate their way through this behavioral analysis and target the most common behavioral issues. Question 3. How does your solution determine the key influences behind over or underutilization And how do you plan to validate these predictive patterns over time? Through the combination of descriptive and predictive analysis. The descriptive analysis utilizes the source data within the Power Query to create insightful measures that are associated with schedule and cost adherence. For example, taking forecast hours versus the EAC hours to identify variances and outliers. These are flagged as part of the visual insights from the dashboard. This is using the graphs and tables. The predictive LNM is then used to review this source data and identify these behavior patterns. Of course, it advises the corrective actions to improve adherence.
We've been able to detect chronic overload, volatility, scope creep, and dependency ignorance, link data to human or process behaviors and inferred behaviors such as optimism bias, reactive planning, and thereby reducing critical path risk. Highlighted resource hoarding, uncaptured over time smoothing or leveling issues. We'd like to further combine qualitative and quantitative data and compute those metrics using Python and BI and expand on our existing work. We've used the large language model to explain what behaviours they've represented, moved us from potentially a static behavioural decision support tool to a dynamic project health monitoring tool. With real project data, including generics, we could tailor thresholds for items such as high slippage or volatility. We could look at weighted behavioural scoring, combining multiple indicators into a risk index and provide higher accuracy to the RAG ratings. We can enhance our visualizations to support robust decision making.